We can use autograph to put data points in and then use the equation of the line to find the function that describes those points, those data points. So let's first of all look at entering a data set. That's this button here. If you can't find that button, go to data and it will enter XY data set. And then you can put your values of the data in. So if I put some data points in, I hit a data point 2, return, hit another data point 6, hit another 3, hit another 9, return 3, hit another 4, back to 4. This one will be 12. What I'm doing is I'm timesing each one by 3, so if I now do this, I get, hopefully, points which will lie on a straight line, because all I'm doing is multiplying by 3. Can't see any data points on there, so if you can't see any data points, what you need to do is to zoom out, which is this button here, until you do see the data points. And here they start to appear. Now I can play around with the axes. I can zoom in on the x-axis, which will, this area here, at the moment, between here and here, are all the data points on the x-axis. So if I zoom in on the x-axis, I'll spread out those data points because I make the x-axis a bit of a smaller scale. So in that way, I can spread out the data points. So if your data points don't look as though they're on the graph very nicely, you can adjust the axes until they do. This hand tool allows you to drag the graph about, because often we're only interested in this first quadrant here. So now what I'm interested in is finding out the equation of the line that describes these, goes through these data points. So I'd go to here and hit this button, and I can enter an equation and literally type in y equals mx plus c and hit OK, and it puts on the equation of the line. And it sets the constants m and c as 1. So if I put in y equals mx plus c, y and x are always what autograph recognizes as the variables, and it puts y up this axis and x along this axis. Any other letters that you type in, it assumes are constants. And so then this will become available, this constant controller, which allows you to change the values of the constants you've entered, in this case m and c. So I can change the value of m, I can literally type in the value, or I can use these buttons to increase or decrease the value. M is the gradient, so it's not surprising that if we increase the m, the gradient increases. If we do decrease it, the gradient decreases. If I make the gradient go 0, then we get a horizontal line, which you would expect, and if I make it go negative, we get the negative gradient. All I have to do now is adjust the value of the gradient until it lies roughly parallel with the data points, which is about there somewhere. 3, which you might have expected because I multiplied by 3, that's my multiplying factor. Now I adjust the position of the line using the y-intercept constant. I can make the line go up or down the y-axis, because remember c is the y-intercept. So now I adjust c until the line coincides with the data points, which in this case will be at 0 because there's no constant that was added. So now I know that the gradient of the line that describes these values is m. And so I can write the equation of the line, which is y equals 3x. And if you think about the data points, what do I do to get y? Multiply x by 3. So it's allowed me to find what the relationship is between y and x. And that's the sort of thing I'm going to ask you to do. You need to adjust the data set until you've got a plot in the correct thing, so that when you put them on the axes you get a straight line. Once you've done that, you then find the equation of that line by using the software.